All right, last section in chapter 2, 2.3 stem and leaf displays. Um, you've done these before. This would be a good refresher though. Basically, if you know how to figure out the stem, you'll be able to figure out the graph. This is exploratory data analysis. EDA is the process of learning about a data set by creating graphs. Histograms, stem and leaf displays. EDA is specifically looks for pattern and trends to see what's happening with the data. EDA also identifies extreme values. I like to call this descriptive statistics, and EDA is basically looking for some like abnormality in your graph and studying the way you look at the graph, whether it's like the skewed left, skewed right, or maybe how long the boxes or the whiskers are, the box and whisker, or maybe how big the numbers are in a stem and leaf. And in a histogram versus stem and leaf, in a way they're similar because they both represent, in a way, the height of a bar is the frequency of a number. In a histogram, you've got the data organized. The only issue is you lose the specific data set. You just know how many numbers are in a class if you read a histogram. You don't know what those numbers were. Whereas in a stem and leaf, those numbers are still there. You don't lose the actual initial data involved. Okay. It can still kind of help you with skewed left or skewed right and all that stuff and identifying outliers as well. Right. To make a stem and leaf, make sure that on the left you have your stem, on the right you have your leaf. Align all the stems vertical column by increasing order with a vertical line to the right. Place the leaves with the same stems in the same row as the stem. Rearrange in increasing order. Label to indicate magnitude of numbers in the display. Include decimal position in the label rather than stem and leaves. I'll talk about that last one. That's pretty much big key. The rest of it you're pretty used to doing before. But here's the raw data. You got data that are in the tens position. The first data was 35. So your stems went by each of the tens position. You've got 20s, 30s, 40s, 50s, 60s, and 70s. So the data of 35 gets 3 as the stem, the tens position, 5 as the leaf, the ones position. Okay, ends up looking like that. So that was the original data. And here's where it keeps the actual data intact. Like I know how many numbers were in the 20s, how many numbers were in the 30s, 40s, 50s, 60s, and 70s. But I also know what the numbers were. Like this is 31, 32, 32, 34, 35. I could go back and give you a list of what the actual numbers were that built up the graph. Okay, got a label, make sure there's a key. So it's the age of employees. 2/5 represents 25 years. That way you know that, hey, 2.5 isn't 2.5. It's rather 25, the age of the years. So here I got the stem and leaf plot. It is the total points scored in the past 35 championship games. I believe it's basketball. Looks like a lot of the numbers are in the hundreds. There are a couple that aren't. But I'm going to use my stem as the numbers in the hundreds and tens position. This is what I came up with. Yeah, it was from Conference Basketball Championship. 143 was 14/3. 13/1 is 131. And when I came to the numbers that didn't have 2 digits, I just put a 0 in front. So it's 0, 8 is with the 3 is 83. Basically, your leaf is going to be the last number. So if you have, like it says, a score of 125, your stem is 12, your leaf is 5. Score of 83 gives you 8, and your leaf is 3. Okay, make sure you leave a title. So here's your title and a key. So the key tells you what one number represents, so you can kind of look at those. I think of it this way. If you were to tilt your head to the right, doesn't that look like a histogram? The height is the height of each bars. So it looks like it's symmetrical, not perfectly symmetrical, but pretty darn close. Maybe with the class of 10 being bigger than class of 12, it stops it from being symmetrical. So you get the same idea of outliers and what it looks like there too. So again, here's some stem leaf problems. Work through a couple of those. Have a good idea what's going on, and we'll practice this in class just like we've done so far too.